Thanks, Mike. So we have next Shawn from Parity Technologies. So Parity Technologies is responsible for the most powerful Ethereum client. So the Rust version to Geth's Go version of Ethereum. And they also have a Zcash client, a Bitcoin client, now a Polkadot client, and I'm sure they're going to be working on other blockchain clients too. They're based in Berlin, and it's the company Gavin Wood founded after leaving the Ethereum Foundation to kind of build enterprise software as well as just open source software for the decentralized web. So Shawn is going to give us an update on Substrate.
Hey everyone. Yeah, okay, so I have a pretty interesting talk and a demo, so we'll see if I can get it all done in the short amount of time. I talk a little bit fast, so I'm sorry. You can wave your hands if you want me to slow down or anything like that. But I'll be talking to you today about enabling forkless blockchain upgrades with Substrate. First, a little about myself. My name is Shawn Tabrizi. I'm a software developer at Parity Tech. My background, I spent 4 years at Microsoft working on identity authentication, also working on their Azure cloud platform. In my time at Microsoft, I was doing some Ethereum dApp development, and then more recently, I joined Parity to do Substrate development and build new runtimes. So in my talk, we'll be talking about Substrate, Rust, WASM, blockchain upgrades, of course, and then building on Substrate and how you all can leave today and actually get started building on Substrate if you wanted to. So let's do a quick review of blockchains. I think most people here are pretty familiar, but let's just get to lay a groundwork. So blockchain is really just a set of nodes that connect together on a peer-to-peer network. These nodes have a database, have a peer-to-peer network system, something like libp2p that we just saw, a consensus algorithm, transaction handling, and a state transition function. And when these nodes connect, they're able to produce blocks and go from block to block, and of course achieve consensus through that. And this is what we really, the main components of a blockchain. So let's talk about how blockchain development happens today. So you might be familiar with things like Bitcoin and Ethereum. These are kind of, I think, blockchain systems that were built from the ground up. But a lot of new blockchain systems that are being developed are actually just forks of these repos. Like you might know like Zcash or Litecoin, which are just forks of Bitcoin client, or you have things like the POA network, which is a fork of the Ethereum node or the Ethereum code base. And so really, when you're talking about building new blockchains, it's really quite hard, and it takes a lot of work, and there's a lot of different layers involved. And really, the easiest thing if you want to make a small change or kind of make something that's custom for your own, you really just fork an existing chain and maybe modify or tweak some parts of it. Parity, on the other hand, has a lot of experience building blockchains from the ground up. We have built at least 3 working clients right now: Parity Ethereum, Parity Bitcoin, and we're working on the Polkadot implementation, Polkadot relay chain. We're also working on a Zcash client and a Filecoin client. And so we've, I guess, in our time here at Parity, have really built the entire stack and worked a lot of times. And it was really through building the Polkadot relay chain we said, hey, we've done this a lot before, and there's a lot of reusable components, a lot of things. It doesn't make sense for every new project to start from the beginning. So really, it was through Polkadot where we decided to come up with Substrate. And I'll tell you a little about Substrate right now. So what is Substrate? Well, Substrate, and you've heard about it kind of all day today, but really is an open source, modular, and extensible framework for building blockchains. It provides you with all of the core components you need to build a blockchain. Those things like a database layer, a networking layer, consensus engine, transaction queue, and a library of runtime modules. And the coolest thing about this is that all of these components can be customized and extended. And so if you're looking to build a blockchain, it really makes sense to kind of start on this like modular extensible framework rather than trying to fork something that's kind of this code base which is monolithic and is like all tied together, and you're trying to figure out how am I going to get everything done. And really, the library of runtime modules is kind of one of the coolest things that makes Substrate so approachable and extensible for the average user. So let's talk about what a runtime is. Well, a runtime really is the block execution logic, the thing we might call the state transition function. It really takes and executes the logic that goes from block to block, what is allowed on your chain, and what can be done. And in Substrate, we give you a library of runtime modules, this thing called the SRML. And it's from it you can pick what components you want to add to your blockchain to basically make it work. So we have all these different modules. You can pick and choose which ones you want. Maybe you just want a balances module, so you can just have just a normal like token chain. Maybe you want to introduce things like governance. You want to introduce things like staking. You can go and pick and choose and add from all this. And we've actually pre-built this all in Substrate. And one of the greatest things too is that you can also build your own runtime modules. And then, of course, extend your own blockchain. We've made this, again, really modular, really easy to extend. So if we look at the architecture of Substrate, you can see here at the bottom we have a WebAssembly layer, consensus, and a libp2p, which is all written in Rust and built into the native executable. And then within the WebAssembly layer, we have something called the runtime. The runtime is also written in Rust, and it's compiled to both a native executable and a WASM binary. And we kind of a little bit heard of WASM a little bit earlier today, but we'll talk more about it right now. So as you may see, Substrate is built using Rust and WASM. So let's talk about why WebAssembly. Well, WebAssembly is a platform-independent executable format. It's built for the web. It's made to be really fast, really compact, really safe, and really well supported. So WASM is actually a platform that's supported by all major browsers, by a lot of big companies. I think the W3C, which includes things like Google, Mozilla, all that kind of stuff, are all supporting this platform. And so when we talk about, kind of thinking about what kind of platforms or execution environments we want to compile down to, WASM is a really great choice. And then why Rust? Well, Rust actually goes really well with WebAssembly. Not to mention that Parity, my company, myself, our company, is a Rust company. So all those different blockchain nodes that we built in the past were all built using Rust. But it also happens that Rust builds directly to WASM, and it allows us that when we build Substrate, the runtime, into both native and WASM binaries, we can use the exact same code base and just have Rust compiled to these two different formats. Parity has built a WASM interpreter in Rust, so that if you have a Rust project and you want to execute some kind of WASM binary, you can do so in your project. And really, using Rust and using the, basically Rust doesn't have any overhead, doesn't have any garbage collector or anything like that. You can actually create really small WASM files when you use Rust to compile to WASM. And it's because we have really small WASM files that we're actually able to store this WASM on-chain. So this runtime, which is built to both native and WASM, we can actually put the WASM file on-chain in the storage and reach consensus about it. And this is what actually enables us to do forkless blockchain upgrades. So let's talk about that. So let's talk about hard fork upgrades first. This is what happens today. So if you have a blockchain and you go make an upgrade to your blockchain network, some new software that has some breaking change, then you release this executable to the world, what's going to end up happening is that people who have upgraded their software are going to fork from the old chain, where the both logic is not necessarily compatible with each other. So you'll have some people who did upgrade running basically one chain, and people who didn't upgrade run a different chain. These chains will not be able to reach consensus with each other, and you basically fork the network. Now, through a lot of coordination and through a lot of kind of community outreach, you can actually get people to all kind of agree when to upgrade, how to upgrade, etc. But really, this is kind of a problem that will persist for any like modern blockchain today. But Substrate provides an alternative here, a forkless runtime upgrade. So as I mentioned, because you have these really small WASM files and you can store them on-chain, we can actually reach consensus about what the runtime of your blockchain is at any particular block. And we have some simple logic on the chain which says, if the node you're running, the executable, matches the on-chain version of your runtime, then you will actually run what's the native executable on your computer, the fastest possible thing. But if your native executable is not the same version as the WASM on-chain, we will actually use our WebAssembly interpreter and take that runtime that's on-chain and run that instead. So you'll be able to maintain consensus with the network. It'll be a little bit slower because, again, if you're running in a WebAssembly interpreter, you're not going to get the true native speed. But you'll be able to maintain consensus and wait, and then you'll be able to then upgrade your chain whenever you want to use the latest native binaries to then get the full speed again. But the whole point here is that because we can reach consensus about the runtime, because the runtime lives on the chain, we can actually make sure that there's never any forks, there's never any departure from people reaching consensus and maintaining their node up to sync. And so we've actually seen that there's actually a need for upgrades. I guess all the time you're seeing new upgrades come out for things like Ethereum, every once in a while for Bitcoin, stuff like that. And these are really, to try to fix important security vulnerabilities, to change core rules in the protocol and add new functionality. So upgrades, people might say like, oh, blockchains must live forever, and maybe they're perfect as is, but it's really not true. And they really need to be upgraded as time goes on, as people find new problems or technology moves forward. It's really important to maintain, keep your blockchain up to the latest tech. And you can even repair chain state and stuff like that with upgrades. And the biggest problem right now really is that hard fork upgrades require a lot of coordination. As I mentioned, you need to contact a lot of people, get people to I guess take down their nodes, upgrade the software, all that stuff. And there's really unclear governance and signaling around these upgrades. So if you're familiar with things like Ethereum, it's been hard right now to get to consensus about what we should be doing, what are the right upgrades we should be making, and really it's just not a clear process. But having this on-chain upgrade system really makes things a lot simpler and keeps, I guess, governance on-chain in logic that you can control. So let's talk about governing runtime upgrades. So yeah, so if you use Substrate, your runtime code that's stored on-chain is accessible through the consensus module. We provide 2 modules which allows you to access upgrade of your runtime. One is a pseudo module, which is more used for like testing or or like private networks, where you can basically have a key which has direct access to do upgrades to your chain. But more commonly in a public network, you might want like this on-chain governance system. So we provide something like a democracy module where users can vote and figure out like if they want to upgrade, they can go through different voting patterns and have different governance mechanisms. And of course, you can build your own module and logic around runtime upgrades. And finally, I guess runtime upgrades are optional. So if this is something that you don't even want on your chain, if you want your chain to be permanent or you want to follow the normal hard forking procedures, you can just not include runtime upgrades at all. But again, it's an option that's available to you through Substrate and really makes, I think, the idea of creating a network and iterating on it much easier and faster and really just better. Yeah, and so I want to really quickly talk about extending and upgrading your Substrate runtime. So because we have these things like Substrate or these runtime upgrades, we can actually use them to extend different Substrate runtimes. So one of the things we tried to do to test the usability of Substrate was we actually built a CryptoKitties-like runtime. So if most of you are familiar here with Ethereum, you might be familiar with the CryptoKitties, a really popular DApp, where basically you can create these non-fungible tokens, trade them, and play with them, pretty much. And we wanted to build something similar like that on Substrate to kind of test how usable Substrate was. And one of the things runtime upgrades allows you to do is actually extend it and improve your DApp chains, like the CryptoKitties app. So you might be able to add new features and functionality, add new storage items, or even repair or upgrade existing storage. And that's what I want to show you in a demo today. So a little caveat here, I'm going to be programming in this little corner. This is the first time I've done this demo, so let's see, hopefully it all works. But what I'm going to be trying to do here is I have a Substrate chain, which runs the CryptoKitties-like DApp chain. And it has an existing storage structure for a kitty. I'm going to go and take and modify that storage structure, add a new property to the storage structure, upgrade my chain, which will migrate all of the existing kitties in, that chain to use the new storage structure, and kind of show you how it can all happen live without a fork. And hopefully that's what I'm going to be doing here. So let me get at my project. So let me show you a chain running. So I have something set up already. I had the project here, which has the CryptoKitties app running. You can see here there's blocks being produced. And if I refresh this page, you'll see here I have some cats. So first, let's just show that it works, and I'll add a new cat for Alice. So I can create a kitty. When a block gets created, it's about every 10 seconds a block gets created, you'll see a new kitty appear here. Yep. So you can see this is an app that works. Now let's say I wanted to add a feature to my app, which doesn't exist right now, which involves some kind of like cat races. So I want to add this new property called speed to my cat. So I'm going to go ahead and do that. So first, let me update my UI. Okay, I'm going to put the mic down real quick. And basically here I just added a new property, and you'll see this property really is not populated right now. So every cat has a speed of 0. And so this is what we're going to fix. We're going to go into our runtime, actually add this new property, and add some values for all these cats, which, again, were already created in our existing blockchain. So to do that, I'm going to go into my Substrate Kitties project. This is the actual Substrate node that I'm running. And this here is my custom runtime module. So here I have all the things needed to run this Kitties module in my Substrate chain, which is already made. So I'm going to kind of run through the different steps here. Actually, give me 1 second. I have a little notepad of making sure I don't forget to do anything, because I wanted to compile the first time. All right? So first thing I'm going to do here is actually take my existing kitty struct, which you see has like an ID, DNA, price, generation. And I'm going to copy it. And then I'm going to create a new struct. So this struct, we're going to call it kitty old, because that's the old kitty structure. We have our new kitty struct. I'm going to add speed. We'll make this a U64, right? And then what I'm going to have to do here is then create a new storage item for the new kitties. So basically, I'm going to take all the existing kitties, which already are in storage, and I'm going to migrate all of them to a new struct using this new thing. So I'm going to, if I can do this, I'm going to copy this storage item over here. We're going to name the old kitty old, and it's going to use the old kitty struct now. And then I have this kitties v2, which has kitties, and it's going to make this new kitty struct. Okay. And then what we're going to do here is we're actually going to do, we're actually going to add one more thing here, which is a version. So one way we're going to keep track in a runtime what version we're using is we're going to actually add a new storage item, which tells us what version we're at any point in time. So here is that. So that's as easy as it was to create some new storage items. Then what we're going to do is we're going to take advantage of a special function called onInitialize. OnInitialize is a function that can run at the beginning of every block that will execute some logic. So here we're going to run so function onInitialize. And basically, we're going to define on the beginning of every block, we're going to check what is the version number. If the version number on that block that's running this node is 0, we're going to make some change to the thing and upgrade the version number. And that's basically what we're going to do right now. So let's do that real quick. So first, I say like if version get equals 0, and that's the for an unset version it's 0. Then we're going to go loop through every kitty. So for I in 0 dot dot, and we're going to get the all kitty count. Basically, this is we're trying to figure out the number of kitties we have. So all kitties count. Hopefully this works. Okay, and then we're going to take from basically we're iterate through every cat, and for each cat we're going to take all its properties and migrate it to the new kitty. So first thing we have to do is get the hash of each kitty. And sorry if this is a little bit obscure here, so we'll say let kitty hash equals what's this? Kitty by index of the I. Then we'll say let kitty. So now we're going to pull the existing storage structure there, which is the old kitties object. So it'll be kitties take kitty hash. And so we're actually using a special function here called take, which basically in storage will not only get the value, but also remove the value from storage. So here, we're not just copying the value, we're saying we copied the value to this variable kitty, and we've actually deleted the value in storage. So here, we're not actually taking up any additional storage space. We're doing a true migration of the storage. Then we're going to make a new kitty, so new kitty, and we'll say that this is a kitty v2. Oops, actually, I want to change this around real quick. Sorry, I want to do this real quick. Sorry, this is kitty v2. This is using the old kitty. Yeah, I'm hoping this all works at the end. If not, I have a backup plan. But so we have kitty, and then we'll be basically going and migrating all the different options here. So we'll take this. Move this over. Kitty.id. Kitty.dna. Again, here I'm just copying all the old values into our new structure. Kitty.gen. And then, of course, we don't have a speed value yet, so we're going to add one. We're going to add, let's say, like 13 or something. And then, at the very end, so now we have created a new kitty struct. What we can do is we can put the new kitty into storage. So we do, give me 1 second here. So we're going to do kitties t insert the kitty hash, and it's basically a mapping a kitty hash to the new kitty object. And then finally, we're going to upgrade our version, because again, at the end of this process, we have now upgraded the version of the thing. So we'll do version put 2, and then we can also emit an event at the end of this upgrade that says that we've upgraded kitty. So we can do like version upgraded. So here's a structure where we're declaring all the events, so it'll be really easy to add a new event. And we can have the event emit a U64, and at the very end, we can basically emit an event. So let's go grab this existing little snippet here, and we'll move it up to this onInitialize at the very end. No, I want to do outside this block. Give me 1 second real quick here. And then we can basically put the new version. So version upgraded. And we want to basically put emit 2. And then we have to go through and basically manage a little bit of our variables around here. So I'm not going to finish this full example to make it fully work, but I'm going to say that what you do from here at this point is basically go and just change some of the things from kitties to kitty v2, etc. And I'll show you the upgrade happening on an existing version. Basically, you can see here what we've done is taken advantage of on initialize, which runs at the beginning of every block. Check the version. If the version has not been upgraded yet, upgrade it, and then set the version on your blockchain to be the new version. So let's go back to our chain. And I will select runtime to be upgraded. I'll pick this v2 runtime upgrade. I'll click upgrade. And what we'll see here is a new event getting emitted once this upgrade happens, that a sudo happens. So this, again, is a forkless runtime upgrade just happened. We use the sudo module I mentioned before, the admin module, to actually upgrade this runtime. And when a new block gets created that uses this new runtime, you'll see another event be emitted, which is the version upgraded. Hopefully that will appear soon. Yep, did it happen? Give me 1 second, trying to debug. Let's see if I refresh this page, what happens. Yeah, okay, so for some reason it didn't emit the event, but you can see here that I have on my UI an update UI for the new kitty version. So, and you can also see here at the top, this is now Substrate Kitties v2. So it detects that my Substrate runtime has a new version here. So what I'm going to do is go into my UI real quick and basically just change where I'm pulling the kitties from. So instead of calling kitties, I'm going to call kitties v2. And if I save this and I refresh the page, you see here I have all my kitties again, but now with the speed of 13. Exactly what I talked about here. So before we didn't have a structure with this value, we now upgraded it, we added some information, and we basically done a full forkless runtime upgrade and also a storage upgrade. And so this is, again, what makes Substrate really powerful, and I think you saw kind of how simple it can be to make these changes and edit your own runtime. So I have just 1 or 2 more slides at the very end to talk about. Let's go back to here. So we did a live upgrade, no problems. So all the instructions to get started building on Substrate and to build your first runtime and to build this CryptoKitties runtime that I showed you is available online in a workshop that we have. So if you go to this tinycc/Parity Substrate workshop, you can actually learn how to run a local Substrate node, learn how to runtime development, best practices, learn about building a working chain with a UI, and you really don't need that much Rust experience to actually get started here. So if you wanted to try to do everything I just showed you here, kind of getting a full Substrate Kitties runtime running, you can actually do that today. So to kind of give you an overview again, what we talked about today was Substrate. What is Substrate? How it uses Rust and WASM to enable this thing called Forkless Runtime Upgrades, and how you today can get started hacking on Substrate. We're hiring. If you're interested in anything I talked about at all, you can take a look at some of the jobs that we have available at parity.io/jobs. We have some events and updates that you can subscribe to at our newsletter, and I'm here to answer any questions. Thank you. Yes, a question in the back. Yeah, so I mentioned, so the question is, how do you maintain the security around maintaining the WASM runtime and the WASM runtime upgrades? Yeah, on the blockchain, yeah. And so again, as I mentioned here, that the runtime is just a part of your blockchain storage, and it's stored in a special key. And you can basically create any amount of governance or any amount of logic you want to control it. So in the example I showed you here, I had a sudo module, which is basically an admin who had access to directly control this thing. So that might make sense for a private chain. But for a public chain, it might make sense to introduce something like democracy or some other type of governance system. And so we actually have a module called democracy, where users can say, I propose some chain upgrade. Users can vote for or against that upgrade, and then it can happen. And again, these are versus kind of existing governance, where you have off-chain governance. Substrate enables this on-chain governance system. It actually makes on-chain governance one of the primary focuses of the security model around Substrate. And it really believes that when you have the clear on-chain governance, it makes the whole decision process around what we should be doing with our chain, what kind of upgrades we're making, a lot more visible, clear, and easy to access, really. Did that answer your question? Okay, great. And again, you don't have to use only our modules. You can create your own module. If you want a module that says, on Wednesdays you can do upgrades, you can do that, you know? Say that one more time, please. Yeah. Yeah, so if you use the sudo module, it would be a whitelist. But basically, yeah, anyone who has access to do runtime upgrades would be something through the logic of your blockchain. So your runtime would have some logic around whether or not you can access that runtime on-chain WASM runtime. Again, you don't have to include any logic. So you could have it so there's no way to touch that on-chain WASM runtime. But if you want to include it, you can basically build whatever logic you want around that. Any more questions? I just lost my screen. That's fine, that's fine. There's nothing, there's that. All right, no other questions? Okay, thank you then.